On the modern day periodic table, the chemical elements are arranged in order of increasing atomic number. So for example, hydrogen is atomic number 1, helium number 2, lithium 3, beryllium 4, and so on. The elements are also arranged according to their chemical properties. So elements in the same group have got similar chemical properties. For example, group 1, the alkali metals, are all very reactive metals. You can also be asked how the elements are arranged in terms of their electronic structure. And the group number tells you the number of electrons in the outer shell. So for example, group 2, something like calcium, would have 2 electrons in the outer shell, whereas in group 4, you've got carbon that would have 4 electrons in the outer shell. And then the period numbers, the rows, the period number tells you the number of electron shells that element has. Now, the modern day periodic table that we see here and the one that you get in your exam is a result of many different scientists' ideas trying to classify elements into an order. And you need to know about those different ideas for your GCSE Chemistry exam. So that's what we're going to look at in this video. The problem the early scientists had was that new elements were being discovered all of the time, like hydrogen, nitrogen, fluorine, oxygen, lithium, carbon, beryllium, and so on. And they wanted to find some way of putting them into an order or some sort of classification system so that it all started to make sense. So in 1808, John Dalton arranged all of the elements that were currently known in order of increasing atomic weight. So you can see here hydrogen 1, helium 4, lithium 7, and so on. Now his periodic table didn't look exactly like this. I'm showing you this to show how you can arrange the elements in order of increasing atomic weight. And that's exactly what John Dalton did to start with. Then in 1817, Dobereiner started arranging elements in groups of 3 called triads. And within those triads, there were groups of 3 elements that had similar chemical properties. And he also noticed that the middle element had an atomic weight which was an average of the other 2 in the triad. So he thought he was really onto something. The problem was there was only a few elements that he could put into groups of 3. Everything else didn't fit in with this pattern. So that idea wasn't taken up. In 1864, John Newlands went back to ordering the elements in order of their atomic weight. And when he did that, he noticed every 8th element was similar to the 8 elements before it. So for example, if we start with helium, which we now know is an unreactive noble gas, and count on 8, 1, 2, 3, 4, 5, 6, 7, 8, we get to neon, which is another unreactive gas. And he saw this repeating in several areas. So he called this the law of octaves, named after the musical scale, because on the piano, if you start at middle C and count on 8 white notes, you get to another C note. So his law of octaves was that put them in order of atomic weight, and every 8 elements you get a similar element in terms of its chemical properties. However, that only worked for about the first 20 elements, and there was a lot more elements than that that had been discovered at the time. So once again, that method wasn't taken up. In 1869, Dmitri Mendeleev, often called the grandfather of the periodic table, came up with something very similar to what we know today. He ordered the elements in atomic weight order, like people before him, but he also started to put them into groups of elements that had similar chemical properties. So here, for example, we've got what we now call the alkali metals, some very reactive metals. But crucially, the thing he did was he left gaps. So for example, if he thought this element should have come next, but he thought it was more in line with the properties of this group, he left a gap and put it in the same group with similar properties elements. And then those gaps were left for any undiscovered elements. So at a future date, when that element was discovered, it could be put in the right place in the periodic table along with similar elements in the same group. So like I said at the start of the video, the modern day periodic table is now in order of atomic number, increasing atomic number. The group number tells you the number of electrons in the outer shell, and the period number tells you the number of shells there are. So if you found the video useful, please give it a like. Thank you for watching.